Welcome to my project bazaar.com. Number using dynamic image processing techniques and genetic algorithms. Let me discuss about the abstract of the project. License plate symbol has been established with several methods. In this paper, a new novel-based algorithm suggested, which is an amalgamation of connected component analysis method and genetic algorithm. An adaptive threshold access is used to solve some elimination problem. Morphological processor is an important process for most pattern recognition, which remove noisy objects. Next, connected element analysis method is grouped pixel into labeled constituents. Extracted object from CCAT are revealed according to their widths and heights. Genetic algorithm phase has been announced to resolve the two-dimensional compound object uncovering problem. Fitness function has been selected by calculating objective distance. Object involving a group of smaller objects and can be used to locate the compound object in an image given that is GRM values are nearly fixed. In this paper, a survey is being localization. Automatic license plate recognition is to extract vehicle license plate information from an image or a sequence of images. In our proposed technique, blob detection and genetic algorithm used to perceive license plate. First, image desired to be transformed to gray image when the input image is in color by dynamic adaptive threshold algorithm used to convert gray image to binary format. Morphological process has been completed so as to achieve elimination of noisy objects. Now our suggested blob detection has been used to label group of parallel pixels. The extracted objects from blob exposure are filtered based on their widths and altitudes of each component. Performed filtering action with a static widths and heights and matched with our calculated parameters. In the next phase, genetic algorithm has been suggested to LP detection. Here objective remoteness and fitness creation has been divided with that they can detect exactly, detecting license text and at the same time distinct it from similar shapes based on the geometrical membership among the symbols. Inaugurating the license number is the selected scheme in this research. Let me discuss about the flow diagram for our process. First, capture the input image from dataset. Here we take in the color license plate images as an input. Next, perform conversion process from color to grayscale. Conversion of color image to gray format has been done by NTSC method. By conversion, we can predict relevant information efficiently. Next, in the adaptive thresholding algorithm. Thresholding is the simplest method of image segmentation. From a grayscale image, thresholding can be used to create binary images. Threshold at each pixel dynamically depending on the average gray level in the neighborhood of the pixel. This adaptive threshold technique used to differentiate between foreground and background pixels. Resulted output with high accuracy rate in different illumination conditions. Proposed real-time adaptive thresholding using mean of local window, where local mean is computed using integral image. However, for thresholding document images, local mean alone does not work as good as considering both local mean and local variance. Next, in the morphological operation, binary images may contain numerous imperfections. In particular, the binary region produced by simple thresholding are distorted by noise and texture. Morphological image processing pursues the goals of removing those imperfection by accounting for the form and structure of the images. Here, morphological operation is performed to fill noisy holes inside candidate objects and to connect broken symbols. Also is applied to remove objects or the thinner than the LP symbols. Next, in the blob detection process, here connected component analysis are used for detecting blobs. Blob detection refers to mathematical method that are aimed at detecting regions in the digital image that are different in properties such as brightness or color compared to areas surrounding those regions. Informally, a blob is a region of a digital image in which some properties are constant or vary within a prescribed range of values. All the points in a blob can be considered in some sense to be similar to each other. When some property of interest expressed as a function of position on the digital image. There are two main classes of blob detectors: differential methods, which are based on derivatives of the functions with respect to position, and the methods based on local extrema, which are based on finding the local maxima and minimum of the functions. There is blob detection in image domain with application to object recognition or object tracking. This process can be applied in other domains such as histogram analysis, peak detection with application application to segmentation, texture analysis, texture recognition, and interest points for white baseline stereo matching. Next, in the size filtering, the object extracted from CCAT method are filtered based on their widths and heights, taken static heights and widths compared with their each components. Next, in the filtered size are transformed into the genetic algorithm in order to obtain the optimization results. Algorithm is stated with a set of solution represented by chromosomes called population. Solution from one population are taken and used to form a new population. This is motivated by the hope that the new population will be better than the old one. Solution which are selected to form new solution, that is offspring, are selected according to their fitness. The more suitable they are, more chances they have to reproduce. Outline of the basic genetic algorithm: generate a random population of n chromosomes. Suitable solutions for the problem: fitness, evaluate the fitness function f of x of each chromosome in x in the population. Next, create the new solution of the population by repeating following steps until a new population is complete. Next, select two parent chromosomes from a population according to their fitness, that is the better fitness, the big chance to be selected. Next, with a crossover probability, crossover the parents to form a new offspring, that is children. If no crossover was performed, offspring is an exact copy of parents. Next, in the mutation, with a mutation probability, mutate new offspring at each locus position in chromosome according to place new offspring in a new population. Next, finally, use new generated population for further run of the problem. If the end condition is satisfied, stop and return the best solution in current population. This process will be repeated for entire population will be extracted. Next, finally, we got the result with the help of optimized result by using genetic algorithm. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and run for executing this process. This is the main window for the license plate number detection. By pressing the input image button, we can browse the input image from the dataset folder. Select any one images from the dataset folder and I display the input image in the axis 1 plot. By pressing the gray conversion button, we can perform the conversion operation from color to grayscale image. So this is the grayscale image I displayed in the axis 2 plot. By pressing the adaptive threshold algorithm button, we can perform the binarization process based on the threshold value. Here I display the binarization result in the axis 3 plot. By pressing the morphological button, we can perform the morphological operation, that is dilution and erosion process. Here I display the morphological image in the axis 4 plot. By pressing the connected component button, we can perform the blob detection operation. So here the blob, that is closed regions, are detected, and by pressing the next button we can move on to the output window. This is the license plate number detection output window, and by pressing the size filtering button we can perform the size filtering operation, that is filter out unwanted region. Only the size filtered, that is mentioned size with heights and widths, are filtered, and this is the displaying process for the size filtering algorithm. And by pressing the genetic algorithm button, we can perform the genetic algorithm operation which provide the optimized result. Based on the optimized result, we perform the license plate number detector. This is the graphical representation for graph. Average values are moved to the best value, and this is the license plate number written in the notepad format, and here I bounded the license plate image with respect to genetic algorithm. Finally, the system proved to be invariant to object distance, indifferent with respect to outlook dispersion within a practical angle interval, and indisputable to a large extent to the presence of other types of images in a vehicle background. Thank you.